In this lecture, I'm going to go through the backup and recovery operations that you can do on the AWS services that you are using. I'm going to start with talking about recovery point objective and recovery time objective, what those terms mean. I'll talk about the concept of incremental backups. I'll talk about RAID and talk about the options for EC2, RDS, DynamoDB, for S3 and Glacier, and then I'll finally talk about the storage gateway service. Recovery point objective, that means the maximum age of files, if we're talking about a file system, or objects if we're talking about Amazon S3, the maximum age of those that are restored from a backup. If we have a high backup frequency, that will mean that we can achieve a low recovery point objective. If we use write or delete events to trigger an incremental backup, that means we can also achieve a low recovery point objective. Recovery time objective. Now that is the maximum amount of time that a system can be down waiting for a recovery to occur. So with Glacier, it can take 3 to 5 hours for us to restore objects from a Glacier archive. So that is something to consider if you require a very low recovery time objective. Glacier is not going to achieve that for you. Full versus incremental backup. So a full backup that captures our entire file system, and it requires a large amount of disk space to do that, because every time that we do a backup, we are basically duplicating our entire data set. Now that does enable us to achieve a fast recovery time objective, but we cannot get a good recovery point objective cost effectively by doing a full backup, because we're not going to be doing regular backups if we're doing a full backup. We're not going to be able to do them in a timely manner. So that data from a full backup may be quite old. The next option there is incremental backups, and that is what we would normally use, where we would capture, we would first do an entire backup or a full backup, and then from that point onwards, we would do incremental backups, and they would only capture the changes that were made since the last backup. That obviously requires disk space, because we're only capturing the changes that were made. We're not doing a full backup every time that we do a backup. The downside is that will take longer to restore from a backup, because our system will need to piece together all of these incremental changes that have occurred to make one recovered data set. But it does enable us to achieve a good recovery point objective. So the data, because we're capturing that on a regular basis, that data will not be that old. Redundant array of inexpensive disks, or RAID. So there are a number of RAID strategies available, but the ones that you should really know for an associate level course or associate level certification would be RAID 0 or striping, and RAID 1 or mirroring. So in striping, there is no redundancy there, and we have our data is distributed across multiple volumes. So we can see there the data in both those volumes on the left-hand side there is different. That enables us to achieve a high storage utilization. It also enables us to achieve high performance rates, because we now have 2 channels of bandwidth to access our data. But of course, we don't have redundancy with striping. With mirroring, we have redundancy, because we're creating another volume with the same data in it. So that does enable us to achieve redundancy. The problem is it is not utilizing our storage very well. So we're doubling up. We need double the amount of storage to store the same amount of data that we would in a striping situation. The other downside is it doesn't provide us with any performance advantage. So we're still accessing our data through one of the bandwidth of one of those volumes. So EC2, backup and recovery. So our AMI image, now that provides a backup of our Amazon EC2 system, and that will be registered and then saved to Amazon S3, and we can restore, or we can recreate an EC2 instance based upon that AMI image. We also have EBS snapshots available, which will take backups of our EBS volumes that are attached to an EC2 instance. And those are incremental snapshots, and they're saved to Amazon S3. Now they are created using the console or the CLI EC2 create snapshot command, and we restore to a new EBS volume and then unmount an existing EBS volume and then mount the new one. And these can be copied to different regions. So the other thing we can look at is using multiple EBS volumes. So multiple EBS volumes configured as a RAID 1 mirrored, not RAID 0 striped. And by doing that, to recover, we can unmount and then take an EBS snapshot and mount again. One thing to consider there is that EBS volumes are replicated by default within an availability zone. So they still do have a decent amount of replication built into them. They are not replicated across regions. So if a region is taken out, then your EBS volume data will be lost. RDS backup and recovery. So we have two options there of automated backups or RDS DB snapshots. Automated backups, they are daily snapshots of data and transaction logs. And the retention period can be from 1 day, which is the default, through up to 5 days we can keep them for. Now, one thing to consider here is that automated backups are deleted when the DB instance is deleted, but we can create a final DB snapshot upon deletion. There is a backup window that can be defined for periodic incremental backups. And periodic backups combined with transaction logs provide recovery up to the latest restorable time, which is usually 5 minutes. So RDS DB snapshots, they are user initiated, they're not automated, and they are not deleted when the DB instance is deleted, unlike automated snapshots. The describe DB snapshots API or CLI command can be used to list the snapshots for an instance, and the delete DB snapshot command can be used to delete a snapshot. DynamoDB backup and recovery. So we don't have automated snapshots as such with DynamoDB, but we do have a table import export function, and that is accessed through the console, and we can export table data and log files to Amazon S3. We can also decide how much of our table's provisioned throughput will be allocated to the export process, and that can be from 10 to 100% in 5% increments. So we don't sacrifice our day-to-day use of our DynamoDB table to do that backup. We can actually have it to be just 10% of our provisioned throughput. It can be set up as a daily export to occur, and it is very simple and easy to restore back to that DynamoDB table from a export or from with an import operation. S3 and Glacier. So as we know from our S3 lectures that there are lifecycle management rules that we can implement. So we can have S3 object deletion after an expiry time, and then have S3 object archiving over to Glacier after that expiry time. And we can restore back to S3 from Glacier, but it takes 3 to 5 hours. So we need to take that in consideration if we require a very quick recovery time objective. Storage Gateway is a service that you will need to have a little bit of an overview of for the associate level certification. You don't need to be an expert in it, but you do need to understand what it is. What it is, it enables hybrid cloud storage between our on-premise infrastructure and AWS. And it uses a virtual appliance to connect directly to your local infrastructure as a file server, as a local disk volume, or as a virtual tape library. So what does it look like? On the right-hand side there, we can see we have our customer premises, and our application server will connect through to our AWS Storage Gateway appliance. which will then communicate over our AWS Direct Connect connection or over the internet through a VPN to our AWS Storage Gateway backend. And that will allow us to seamlessly access Amazon S3, Glacier, or Amazon EBS. So the three different options that are available to us are a file gateway, which enables a interface to Amazon S3 with file protocols such as NFS. And our objects inside an S3 bucket can be accessed directly in Amazon S3. The other option there is a volume gateway, and that's an iSCSI protocol access to Amazon S3. And we can access that data in the EBS only through an EBS snapshot to create a new EBS volume. The other option there is a tape gateway, and that is again an iSCSI, a virtual tape library access to Amazon S3. And that data in Amazon S3 can be archived over to Glacier. And it uses virtual media changes, virtual tape drives, and virtual tapes. So that brings us to the end of our lecture on backup and recovery operations. And I look forward to seeing you in the next lecture.